I'd say we probably have about another, well, absent any human effects, we have probably about another, 1 to 2 billion years. It's uninhabitable. Mars lost its atmosphere. Mars was too small. It could not sustain geological activity, and it has lost its atmosphere. There's no magnetic field to protect from solar radiation. So if you did build a colony on Mars, it would largely have to be basically underground.
Currently, our technology will get us around the solar system. When we look at technology to explore the universe, even the nearby stars, if you take a look at the nearest star, which is about 4 light years away, you're talking about a one-way trip of 80-some years. If you can accelerate and fuel that the whole way, it's a quite... The expanse of space is huge. Okay, so a couple of things to really explore the universe. One is, how do you make the efficiencies higher? How do you build these big things? Where do you get the material to do it? It's a way of looking at an entire system that includes everything, all the different sciences, and how it interacts with society and the environment and the whole thing in here. Of course, we're also looking into renewable fuels, the stuff that comes from corn, which we have plenty of here, right? We've got plenty of corn, and although it's not as clean in terms of carbon footprint, it's directly renewable. Okay, you're not going to run out of it as long as you can grow it. And using hydrogen fuels as a way of cutting the footprint, as opposed to the normal kerosene is what jet engines fly on. When you burn hydrogen, the pollutant is water. It gives off water when you're done. So it's a quite clean kind of thing. Of course, we're also looking into the recycling technologies. By going to Mars, are going to explode probably several orders of magnitude. Ultimately, that lets us take that science and apply it here and clean Earth up.
But we must also continue to go into space for the future of humanity. I don't think we will survive another 1,000 years without escaping beyond our fragile planet.
Goal of getting to Mars is a really good scientifically. I think we can learn a lot from Mars, but it is a dangerous mission. I mean, we're talking about a mission that is months or years long. And to figure out things like how to shield the astronauts from solar storms while en route. There's issues of, what happens if and when there is some kind of a situation, because they are essentially cut off. They can't get back to Earth easily.
I'm heading the research group called Aerospace Robotics and Control Lab. So I'm kind of in the junction of aerospace engineering and also robotics. This is our aerial robot that we have developed for our research, bio-inspired flight research. One of the main applications of this bio-inspired flight is to build an aerial robot that can interact with humans. So the main idea is that to send these robots in the very dangerous areas where you don't want to have humans, so that this highly agile, maneuverable aerial robot can relay some video and sensing information back to the human operators.
Let's see, one thing that we need to keep watch out for in terms of space is threats from space. Not just long term, but shorter term, like asteroids. The Earth has been hit by asteroids in the past. I mean, it happened to the dinosaurs. 60 million years ago, they got whacked. About a 7-mile across asteroid slammed into the Yucatan Peninsula. It was now the Yucatan Peninsula, and it triggered a mass extinction. And we don't have any direct threats for like the next few decades, but someday in the next few million years or so, 10 million years, whatever, there'll be another impact event. The question is, you know, can we change that? Can we do something about it? Could we stop it if we detect it early enough? And that is something that NASA has a program to monitor these near-Earth objects, looking for hazardous ones that we may have to do something about. Because the farther in, the more advanced warning we have, the easier it is to do something about it. If you know about an impactor 10 years before it's going to hit the Earth, it's not hard to give its orbit a little nudge so that 10 years from now, that nudge will make it miss the Earth. You find out about an impactor 1 month before it's going to hit the Earth, and now the effort to move it so that it will not hit the Earth is tremendous. 10 years, 10 years before, it's a nudge. 1 month before, and it's nearly impossible. Another thing we have to worry about is making our technology a little more robust in terms of as we get more and more technologically dependent, we become more and more vulnerable to things like solar storms. In astronomy, what we're trying to do is understand the nature of the universe, how the universe works, where we came from, where we are in the universe. Trying to understand our place in the universe. And I mean, so part of what we gain from the technology that we develop for astronomical purposes is understanding the origin of our universe, the origin of our planet, the origin of our solar system, where it all came from.
So remember to look up at the stars and not down at your feet. Try to make sense of what you see, and wonder about what makes the universe exist. Be curious. And however difficult life may seem, there is always something you can do and succeed at. It matters that you don't just give up.